And yeah, if I remember this question correctly, so that's just a huge cancellation at the end. So you have all many terms, right? And then just have to shift them. Well, yeah, shift indices. Well, we can see. We can try while waiting for other people to come. Well, it's near the end of the semester, so it might take a while. I mean, this question is it's not difficult, but it's just tedious. So this is 15.1.3, right? So you start with this series expansion, and it's given in question 2 already. So you have sum of k, this largest integer below n over 2, and to the k power n minus 2k. Oh no. N power, and because it involves a lot of cancellation, so all these terms need to be a little careful. If there's any error in any of these factors, then it might not work out. X to the n minus 2k. Hopefully I copy it correctly. Okay. And then the question is just directly substitute this into the Legendre equation, which is 15.5. So show that minus x squared on p sub n double prime minus 2x p sub n prime plus lambda becomes n times n plus 1 in this case. N equals to 0. Right? So that's the question. Now the only way to do it is this direct substitution. So we need p first derivative and second derivative. The first derivative actually is just multiplied by x anyway, but we did this derivative first, so derivative n prime is just basically
so none of the factorials for the x have just write that as a constant, big fine.
No, you need to, because finally you need to shift it. So if you don't keep this correctly, then you can't get the cancellation correctly, because so basically this one will have this form. This one, after you take the pi, this reduced by 1 power, but you multiply by x, so you still get back the same form at the same coefficient, so you don't need to shift this term. Likewise, x squared times double pi, also you don't need to shift, but this term, this one is because after you take the double pi, this reduced by 2 power, the power reduced by 2, then you need to shift everything in order to compare them. And so if you don't keep this coefficient, the form of the coefficient, then after you shift it, it's not right. Okay, that's why I say I need to copy it correctly, because if I make some error in writing this coefficient, then it finally might not work. Okay, so anyway, let's try. So let's try see if I can get it correctly. So this is pi. So you have this n minus 2k factor out, and then x to the n minus 2k minus 1 divided by what that's copy them. Just one factorial. Okay. All right, so that's Pn pi, and likewise Pn double pi. Let's just keep doing that. Okay. Now you multiply out another one, n minus 2k minus 1, and x to the n minus 2k minus 2, and multiply the whole thing. Okay, and now you need this Pn pi in this term, which is multiplied by x. You multiply by x here, so when you multiply x, you just cancel with this one. So that is nice. And for this one, you need to copy another line because you have two of these. You have this one and that one. So for the second one, x squared Pn double pi is just simple. It's just whatever we have here. And then just cancel this, cancel with this minus 2. So x and minus 2k. So get back to the same power of x. Right? But then you need this term. This term you just decrease by 2. So in order to compare all the terms so that you can see that whether they cancel, add up to 0, it's much better that you shift this back to this power back to n minus 2k. So we do the usual trick. So n minus 2k minus 2 becomes your new n minus 2k. So your ON is your new n plus 2, right? Your ON is new n plus 2. So whenever you see n, it becomes n plus 2. Okay? And no. N is 6, so I get it correct. K is I should actually shift K, not shift N. You should use shift. That's fine. So should be like n minus 2k minus 2 is your n minus 2 new k. Okay, so this is new k. So the old k is the new k's minus 1, right? If your old k is the new k minus 1, then you cancel this minus 2 factor, right? You see that? So this is crucial. So shift this old k to your new k. The new lk is new k minus 1. So that will cancel this one. So whenever you see k, it becomes k minus 1. Okay, and then you figure out this this limit later. But let's write everything first. K minus 1 to n minus 2k. Now it's minus 2, right? Right, not minus 2. K to become k minus 1. So this is plus 2, right? K to become k minus 1 because of the negative sign, this plus factorial. And likewise, this n minus 2k plus 2. And then you have a n minus 2k, k become k minus 1, so plus 2 minus 1 is plus 1. X to the, now it's n minus 2k. Then you have 2 to the power n, and then k minus 1 factorial, and minus k plus 1 factorial, and minus 2k plus 2 factorial. Okay, and now you figure out the limit. So the new k, the old k is new k minus 1, so new k is k plus 1, right? So we start with original k, old k is from 0, so new k start with 1, right? Start with 1. Right. See if I got it correctly. So the new k start with 0, the 0 term is n minus 2. And if your old new k start with 1, so the first term n minus 2, right? So correct. Now come to the final part is see if everything cancel. Now all the terms are in the same power of x to the n minus 2k. So you can just compare the coefficient except the boundary term, the lowest term. So you have 4 terms. So all these terms, this one, this one, this one, the original one is this one, and this one is this one. This one is this one. They all start with 0. But this term start with 1. So for the 0 one, you need to treat it separately. Most likely treat it separately. So for k equals 0, so arbitrary k, see if I got it correctly. Right, so add all 4 terms. Right, there can be some cancellation before we do that, right? Because we also wanted to compare this term and that term because the factorial of all that is different, right? This is why I was because I mean, there's common denominator I want to get out because they all have this term. This is why this is correctly. I want to get back because all 3 terms have all this common denominator. This one, this one, this one, all these are common denominator in everyone. So I'll just write it out. So there's a minus sign, minus 1k. And you have a 2n minus 2k factorial. This is 2n minus 2k plus 2 factorial. So means to get back to that, you have 2n minus 2k factorial multiplied by 2n minus 2k plus 1, 2n minus 2k plus 2. Right? And then I only need that. The rest is just the same. You have this. You actually this one, then multiplied by this 2, you get the square of this. But this is I try to get to n minus 2k factor, right? And the n minus 2k plus 2. N minus 2k plus 1, which is exactly this one or that one. So that. Oh yeah. That's just n plus. The n minus 2k plus 1. There's n minus 2k plus 2. This 2 is the same as this 2. Did I actually? So let's keep it first, and then you have a 2n, And then you have k minus 1 become k factorial multiplied by divided by k. And then this is you have these two m minus k factorial multiplied by n minus k plus 1 and minus 2k factorial and minus 2k. Yeah, that because you take derivative, you get this factor and this factor, and then after the shift, this becomes n minus 2k plus 2. This becomes n minus 2k plus 1, right? Because again, this due to the shift in this, k becomes k minus 1, right? So this k become k minus 1. Right. But anyway,
The 2n, you have 2n minus 2k, which becomes
this is a factorial, right? So this factorial equals to this factorial times this factor, right? This becomes this n minus k plus 1 times n minus k factorial. Oh, yeah, okay. Yeah, I know what you're saying. So the n2, this is 2n minus 2k. Yeah, I look at it incorrect. It's 2n. This is from this to, and you still have this. You still have this 2 factor, but n minus 2k. Yeah, get. Sorry. I might see if I get enough space for this one. It's almost out of the range. So and we still have this 2 factor n minus 2k. Right? Sorry. This is 2n. This is 2n. N minus 2k plus 1. The fact is that you have n minus, this factor cancel with this factor. So n minus 2k plus 1. All right. So, well, but anyway, see if now get so the general terms, it just you have one is this one. So you have this you have everything, the common denominator is this one minus k. So minus k. So everything out of the everything out in front other than the common denominator. You have a minus 1, and then this is common, so you have 2n minus 2k plus 1, 2n minus 2k plus 2, and then k, and then divided by n minus k plus 1, then n minus 2k. Well, no, this is, yeah, this is, this is from here. So this already canceled. Yeah, this already canceled. So we only have this one. Okay.
when you the n minus 2k factorial.
Yeah.
I think when you went from the I'm describing yes.
K prime equal to k plus 1 or k minus k. The new k is it k plus 1?
New k is OK plus 1, right? So k is k new k minus 1. So this is plus 2. Yeah, I say another n minus 2. Yeah, right. Cancel which? Oh, yeah, this term. Yeah, cancel with this term. Okay, so I actually don't have. Actually, so whatever I have, n, this one, and this one, and k, and the denominator is this one, right? Right. So we have 2 factor here, 1 factor here, and then a k. Actually, I have a k, 3 factor here, k, and then just this factor. Okay, so that's this term, and then second term is this one. So now all the common denominators out, except this 2 term, except this 2. This minus n minus 2k and minus 2k minus 1. That's the second one. And the third one is this one, the minus 2 of everything common except this n minus 2k. Right? And the final one is just this one. This. Now, does it look like it cancel? So first of all, it's this one and this one have the common thing. So n minus 2k factor the minus 2, you can put the minus 2 inside, become plus 2 here. We change that, right? You have common factor, put the minus 2 inside because the minus sign become plus 2. This become plus 1. And no, you can put the common denominator out. So 1 over n minus k plus 1. You have minus 2n minus 2k plus 1. 2n minus 2k plus 2k. And then minus 2n n plus minus 2k. And minus 2k plus 1 minus k plus 1 and plus, right? This is common denominator plus times minus k plus 1. Right. That is a lot of any more. Which one?
The second term, the first term, the second, the 2 n minus 2. If you take the 2 out, it cancels.
Oh, yeah. Yeah, you're right. Okay. What? That is better. Yeah, n minus k plus 1. So the n minus k plus 1. So this cancel with that. It's a factor of 2. That is much better. That is much better. Okay. Now you just have or this multiplied together, so minus 2k and minus 2k plus 1 minus 2k minus 2k plus 1. Wait. What did they do? No. This right, I'll explicitly see it. Minus 4kn plus 4k squared minus 2k, and that one has minus n. We actually have n times n plus 1 here, but we need to be a little careful. And n times n plus 1, so minus 2k n minus 2k plus 2k n. No, this is minus n 2k plus 2k n. No, I got it wrong. I multiply this one, n times n plus 1, right? So I take care of this one, and then n times minus 2k becomes plus 2kn. So I take care of this one, and then this one is minus 2k times n, and it's also a plus sign, so again 4kn, and then minus 4k squared, and plus 2k, and then plus this one, plus n times n must basically cancel this one. The 4kn, and then minus 4k squared, 2k and 2k. That's 0. Okay, so the shift is correct. The general term is correct. Now is the boundary term that I'm struggling with the boundary term, except that let's see what that means. The boundary term is what is the boundary term? Boundary term is this term. So I need to exclude this term in the general. I need to exclude that in the general, which is k equals 0, which is k equals 0. But so then this term is contributing to which term? This is the first one, and this is the term. This is this term. But it has a k here. It has a k. If it said k equals 0, so that doesn't matter. Yeah, if there's a k here, and we say k equals 0. K equals 0 is the boundary term. So the rest goes through. Whatever the rest goes through, setting k equals 0 is still 0. And then this, you can set that you're not including this term with k equals 0. Or you can, another way to do it, because you recognize there's a k here, then although the shift required that you start with k equals 1, but you can say you start with k equals 0 because of the k. This k is coming from this k factorial. Because I want a common denominator as this one, so from k factorial divided by k, put it in the numerator. Okay, so the argument now is going from although you have a k, although you have a start from minus a k from 1, but because of the k, you can say start of 0. That doesn't matter because that term will be 0 anyway. Okay, and then I can use this argument for general k, and that is 0. Fortunately, thanks to Atul, recognizing there's a cancellation. All these things just tedious. Anyway, that's sometimes mathematics are like that.